Hello, grade 10s, and welcome back to the next lesson, lesson 2 of motion in one dimension. In the last lesson, we looked at the difference between distance and displacement. And now we are going to look at the difference between speed and velocity. Your average speed is the total distance traveled divided by the time interval that it took for that motion to occur. Now, speed is a scalar, and speed may be defined as the rate of change of distance. Now, if we look at this formula over here, we've got speed is distance over time. Any formula that is over time, you may define it as the rate of change of the numerator. So in this case, speed is the rate of change of distance. If I say to you, x equals y over t, if I ask you to define this, then you would say that x is the rate of change of y. And so that's going to help you with many of your definitions. SAV means the average speed. Average speed is measured in meters per second. D is the distance that we learned is measured in meters, and time is measured in seconds. Now, the reason for the triangle here is because it is the change in time. It represents a time interval over which the motion took place. Speed is a scalar, so we only represent its magnitude. It doesn't have direction. Average velocity, on the other hand, is the change in position, or the displacement, which is delta x, divided by the time interval that it took the motion to occur. Velocity is a vector, so we may define velocity as the rate of change of displacement. If we look at this formula over here, we can see that the average velocity is something over time. So therefore we can use the definition of the rate of change of the numerator. So the average velocity is the rate of change of displacement. The average velocity is measured in meters per second. The change in displacement is measured in meters, and the time interval is measured in seconds. And keep in mind that velocity is a vector, so the final answer has to have both magnitude and direction. For the same motion, the average speed and the average velocity may have very different values. The table below summarizes the differences between speed and velocity. So in the same way that we summarized the differences between distance and displacement, speed and velocity are different in similar ways. Speed is a scalar, velocity is a vector. Speed is always positive, velocity may be positive or negative depending on direction. The speed does depend on the path taken because it takes into account the distance, whereas velocity does not depend on the path taken because it takes into account the displacement. Let's now take a look at how the two are different. So Sarah walks to the shops to buy some milk, and after walking 100 meters, she realizes that she doesn't have enough money, so she needs to go back home. Now, it took her 2 minutes to leave her house and then come back home. Calculate the following. So firstly, how long was Sarah out of the house? Now here we can see that she was out of the house for 2 minutes, but we need to work in SI units. So we need to convert that 2 minutes into seconds. So 2 times 60 is 120 seconds. Remember that when we work out our speed or our velocity, we want our final answer to be in the SI unit of meters per second. So we must make sure that we deal with meters for distance or for displacement and with seconds for time. What was the distance that Sarah walked? Now remember, distance takes into account the total length traveled. So Sarah walked 100 meters and then another 100 meters. So in total, she walked 200 meters. That is her distance. But what was Sarah's displacement? Now in this case, we need to have a reference point and we need to state a positive direction. However, in this case, Sarah's final position was her house, and her starting position was also her house, because remember, she left her house being the reference point, and then she realized that she'd forgotten her money at home, so she had to go back home. So she ended back at the reference point. So the answer is 0 minus 0, which is 0 meters. And when our vector answer is 0, there is no direction associated with it. But now we can see that the distance that Sarah traveled and her displacement are completely different values, which means that her speed versus her velocity will have completely different values. Let's take a look. What was Sarah's average speed? Well, the average speed is calculated as the distance divided by the time interval. We worked out that Sarah's distance traveled was 200 meters and that in total she walked for 2 minutes, which is 120 seconds. So that means that her average speed is 1.67 meters per second. And remember, for speed, we only have magnitude. There is no direction. But what was Sarah's average velocity? Well, now we need to use this formula over here. The velocity formula takes into account displacement. But we already worked out that her displacement over the 120 second time interval was 0. Therefore, Sarah's average velocity is 0 meters per second. And when a vector value is 0, it doesn't have direction associated with it. This goes to show us that the calculation for speed and velocity are different. For the same motion, speed and velocity will not necessarily have the same value. And that's because if the distance and the displacement values are different, then the speed and the velocity values will be different too. Let's now take a look at instantaneous speed and velocity and how that is different to the average speed and average velocity. So imagine a person runs a 200-meter race and it takes them 30 seconds to complete it. Now, when they take off, they are moving more slowly than, say, 20 seconds into the race. So when we work out average speed or average velocity, we consider all the different speeds and velocities during the motion and we average them out. On the other hand, instantaneous speed and instantaneous velocity will look at the speed or the velocity at a particular point in time. So it doesn't take delta t into account, delta t being some sort of time interval, but rather it uses only t, which is a point in time. So again, we don't use the symbol delta t for instantaneous speed and velocity because we're not considering a time interval. So we simply use the symbol t for time. Let's define instantaneous speed. Instantaneous speed is the distance traveled over a very small time interval. So here we've got instantaneous speed, which is distance divided by time, but it's very important to note that this is measured over a very small time interval. So at a particular point in time, at a particular distance, what was the speed of the object? And what is instantaneous velocity? It is the change in position, again, over a very small time interval. So the instantaneous velocity is the change in position over a very small period of time. Now, before we move on, let's take a look at speed conversions. We need to be able to convert from kilometers per hour to meters per second. We also need to be able to convert from meters per second to kilometers per hour. And those are conversions that are going to come up time and time again on tests and exams. Now, I'm going to show you a shortcut version that you can memorize, but I'm also going to explain the logic behind it to you. So in order to convert from kilometers per hour to meters per second, we need to multiply by 1,000 and divide by 3,600. And you can just memorize that. So to go from kilometers per hour to meters per second, you take the value in kilometers per hour times 1,000 divided by 3,600, and that will give you the answer in meters per second. So let's convert 85 kilometers per hour into meters per second. Well, 85 kilometers per hour really means 85 kilometers covered in 1 hour. So we need to convert this kilometers into meters and this hour into seconds in order to get meters per second. So to convert from kilometers to meters, we need to multiply this value by 1,000 because there are 1,000 meters in 1 kilometer. And to convert from hours to seconds, we multiply 1 hour by 3,600 because there are 3,600 seconds in 1 hour. So 85 kilometers per hour means 85 kilometers over 1 hour. So to convert the kilometers into meters, we multiply by 1,000. And to convert hours into seconds, we multiply by 3,600. So essentially what we get is 85,000 divided by 3,600. And if you plug that into your calculator, then you will get your answer in meters per second. It's 23.61 meters per second. So here we've learned how to convert kilometers per hour into meters per second. But remember that I told you that all you really need to do is take the value given in kilometers per hour, multiply by 1,000 and divide by 3,600 to derive your answer. And it's perfectly acceptable to show this working out. You'll get the full marks that are allocated for this question. However, this helps in terms of learning how to use your logic in case you forget exactly what you need to apply here. Now, like I already said, we also need to be able to convert meters per second into kilometers per hour. So to do that, we can shortcut it by saying we take our value in meters per second, we divide it by 1,000, and we multiply it by 3,600. So again, this is a nice shortcut, but I'm going to show you the full logic behind it when we convert 15 meters per second into kilometers per hour. So 15 meters per second means that we cover 15 meters every 1 second. Now we need to convert the 15 meters into kilometers, and we need to convert this 1 second into hours. So to convert from meters to kilometers, we need to divide by 1,000 or divide by 10 to the 3, which is the same as multiplying by 10 to the minus 3. And that's because there are 1,000 meters in 1 kilometer. Now, in an hour, there are 3,600 seconds. So 1 second is represented by 1 over 3,600 of an hour. So we take this 15 and we multiply it by 10 to the minus 3, or we divide it by 1,000. And we divide this whole thing by the 1 second, which in hours is 1 over 3,600. Now, you can just into your calculator plug in 15 times 10 to the minus 3, or 15 divided by 1,000, divided by 1 over 3,600, and you'll get to this answer. Alternatively, this value divided by 1 over 3,600 is the same as saying this value times 3,600. This step over here is not important. I just wanted to show you all the steps leading up to the final answer. So 15 times 10 to the minus 3 times 3,600 will give you your answer of 54 in kilometers per hour. But simply, like I said, what you can do is you can take your value in meters per second and just divide it by 1,000 and multiply it by 3,600, and you'll get your answer in kilometers per hour. So let's convert 60 kilometers per hour into meters per second. So I've used my shortcut method here. Because I'm converting from kilometers per hour to meters per second, I multiply by 1,000 and divide by 3,600, and that gives me an answer of 16.67 meters per second. And to convert 17.65 meters per second into kilometers per hour, again, I use my shortcut method, and I take my value in meters per second, I divide by 1,000 and multiply by 3,600, and that gives me an answer of 63.54 kilometers per hour. Let's now move on to acceleration. Acceleration is the change in velocity divided by the time interval over which it took for the motion to occur. Acceleration is a vector, and acceleration is defined as the rate of change of velocity. If we look at the formula, acceleration is the change in velocity over the change in time. It is the rate of change of velocity. Acceleration is measured in meters per second squared. The change in velocity is measured in meters per second, and the time interval is measured in seconds. Acceleration is a vector, so that means that our final answer will have both magnitude and direction. Now we're only going to be dealing with questions of constant acceleration all the way to matric, which is why we don't need to differentiate between average acceleration and instantaneous acceleration, because if the acceleration is constant, then that means that the average acceleration and the instantaneous acceleration will have the same value. Like displacement and velocity, acceleration can be positive or negative. However, there's some added layer of complexity here. When it comes to displacement and velocity, a positive answer means that the displacement or the velocity is in the positive direction, and a negative answer means that the displacement or the velocity is in the negative direction. Now, it's not as clear-cut with acceleration. In the case of acceleration, a positive or a negative answer depends not just on the direction in which the object is moving, it also depends on whether the object is speeding up or slowing down. So what that means is that if the direction of the motion is positive and the object is speeding up, then we have a positive answer, which indicates a positive acceleration. If the direction of the motion is in the negative direction and the object is slowing down, then we've got two negatives that make a positive. So again, we're dealing with positive acceleration. So the implication here is that a positive acceleration answer means one of two things. Either the object is speeding up in the positive direction or slowing down in the negative direction. So you need to read the question quite carefully to figure it out. If the direction of the motion is positive and the object is slowing down, then we have a positive and a negative, which makes a negative. So we end up with a negative acceleration answer. And if the direction of the motion is negative and the object is speeding up, then again, a minus and a plus makes a minus. So again, we end up with a negative acceleration. So again, if we get a negative answer, it doesn't necessarily mean that the object's moving in the negative direction. It could be moving in the positive direction or in the negative direction. But we need to look at the context of the rest of the question to see if the object's slowing down or speeding up. So this means that if your final answer for acceleration is positive, it is possible that the motion is in the positive direction or in the negative direction. If your final answer for acceleration is negative, then it is also possible that the motion is in the positive or in the negative direction. You actually need to look at the context of the question to figure out if the object is speeding up or slowing down. And then, based on whether your answer for acceleration is positive or negative, you'd be able to identify the direction. Just note that we may not use the word deceleration to refer to a slowing down in the GDE syllabus. Acceleration is either positive or negative, and that depends on both of the properties mentioned above, whether the object is traveling in the positive or the negative direction, and whether the object is speeding up or slowing down. Let's consider an example to clarify this. A car accelerates uniformly from an initial velocity of 2 meters per second to a final velocity of 10 meters per second in 8 seconds. Calculate the acceleration of the car during this 8-second time interval. So the starting point of the car is the origin, and we're going to say let the direction of the motion be the positive direction. So in the first 8 seconds, the acceleration is the change in velocity over the change in time, which is Vf minus Vi over Tf minus Ti. Because remember, change in anything is the final minus the initial. The final minus the initial. The final velocity was 10 meters per second, and the initial velocity was 2 meters per second, so it is 10 minus 2. And the time interval was 8 seconds. The motion ended after 8 seconds, and it started at time equals 0 seconds. So that's 8 divided by 8, which gives us an answer of positive 1. Because it's acceleration, we measure it in meters per second squared. Now, the fact that it's a positive answer either means that the object was speeding up in the positive direction, which we defined as the direction of the motion, or slowing down in the negative direction, opposite to the direction of the motion. But what we know, based on the way that the question was asked, is that the car accelerated from 2 meters per second to 10 meters per second. So that means that the car was speeding up. So that means that a positive answer must mean that the direction of the motion was in the positive direction, which we defined the positive direction as being the direction of the motion. So for acceleration, because it's a vector, you only need to specify the direction, but I like to specify both, whether it is speeding up or slowing down, as well as the direction of the motion. So again, the answer here is positive. We know based on the context of the question that the car was speeding up. Speeding up is a positive. And because our final answer was a positive, that means that the direction must also be positive. And the positive direction is the direction of the motion. Now, this question continues. From 8 seconds to 14 seconds, the car then slows down uniformly to a final velocity of 4 meters per second. Calculate the acceleration of the car from 8 to 14 seconds. So in the next 8 to 14 seconds, we may calculate the acceleration as delta V over delta T, which is Vf minus Vi over Tf minus Ti. Now the final velocity as stated in this question is 4 meters per second, and the initial velocity is based on the previous question where the car accelerated from 2 meters per second to 10 meters per second. So in the previous question, the 10 meters per second was the final velocity, but for this part of the question, the 10 meters per second is the initial velocity. And the time interval, well, the final time was 14 seconds and the initial time was 8 seconds. So it's 14 minus 8. Time will never, ever be negative. But velocity might be, like in this case. So it is minus 6 over 6, which gives us an answer of minus 1. So that means that our acceleration is 1 meter per second, but we need to account for this negative. And a negative acceleration value either means slowing down in the positive direction or speeding up in the negative direction. Now, in this case, obviously, based on the question, when we read it, we're told that the car slows down. So we know that it is slowing down. So that's a negative. We know that our final answer is negative. So that means that the direction of the motion must be the positive direction. And we define the positive direction as the direction of the motion. Again, you don't need to state in your final answer that the object is slowing down. Remember, for a vector, you need magnitude and direction. I just find it easier to state both variables for acceleration. The direction, which we have to state, and whether it is speeding up or slowing down, because that helps me to make sense of the final symbol. The answer is negative, so we know based on the context of the question that the car is slowing down, which is negative, so the direction must be positive, which is the direction of the motion. That brings us to the end of acceleration. In the next lesson, we will start describing motion, and we will start drawing and analyzing and understanding motion graphs.